fiber in your food. To most people, the word starch means just two things: calories and sugar spikes. However, starch actually falls into three distinct categories based on how we digest it: rapidly digestible, slowly digestible, and non-digestible, a hidden superpower known as resistant starch, or RS. Unlike standard carbs, resistant starch largely evades the digestive enzymes in our stomach and small intestine. Instead of being broken down and absorbed, it travels virtually intact all the way to the large intestine. Because of this unique path, it provides less calories, has a minimal impact on blood sugar, and functions exactly like a traditional dietary fiber, selectively nourishing beneficial microorganisms. Today, we are breaking down the 5 distinct types of resistant starch and how you can manipulate your cooking at home to harness these benefits. In the resistant starch family, there are 5 unique types, and they behave differently under heat. RS1 is physically inaccessible starch. It is trapped tightly inside the intact cell walls of whole grains, seeds, and legumes. It's relatively stable during thermal processing, but is substantially reduced by milling. RS2 is raw starch. This is found in foods like green bananas, raw potatoes, and raw oats, where the starch granules are packed in a tight, native crystalline structure. RS3 is retrograded starch. This forms naturally when cooked starchy food is cooled down. RS4 is chemically modified starch. This is an industrially altered fiber used in processed foods, frequently appearing on nutrition labels as modified food starch. And RS5 is a starch-fat complex. This forms when starch molecules bind chemically with lipids during hot cooking, creating a structure that digestive enzymes can't easily crack. Exciting new science shows starch can also pair with proteins and plant polyphenols to form this exact type of structure. As a dietary fiber, resistant starch delivers powerful health benefits. It moderates after-meal sugar spikes, enhances insulin sensitivity, improves cholesterol levels, especially for individuals who are overweight or managing diabetes. The underlying mechanism for these benefits lies in your colon. When resistant starch reaches your colon, it serves as a prebiotic to your good gut microbes, which ferment the starch to produce health-promoting compounds like short-chain fatty acids. These short-chain fatty acids are the real heroes. They reduce inflammation, improve gut health, and fundamentally shift your metabolism. So how do we optimize it in the kitchen? It comes down to food structure and temperature. First, milling. Avoid overly refined flours. Mechanical milling strips away the physical protection of RS1. Coarsely cracked grains retain more resistant starch than finely powdered ones. What's more, if you cook and cool finely milled flour or rice, it creates a fraction of the RS3 you would get from a whole grain. Second, the cook and cool method. While heat destroys RS2, it is mandatory to create RS3. When you cook starches like rice or potatoes, the starch gelatinizes. As it cools, the starch molecules, specifically amylose, recrystallize into a tightly packed, highly stable structure. Chilling your carbs at 4 degrees Celsius in the fridge for 24 hours significantly maximizes this RS3 yield. Freezing can also work well, especially through freeze-thaw cycles. Even your choice of bread matters. Sourdough contains more RS3 than standard yeast-leavened bread due to the fermentation process. Leavening the dough at a lower temperature, like 25 degrees Celsius versus 30 degrees, combined with a slower bake, also helps yield more RS3. Third, heating. High heat completely destroys raw RS2. That's why RS2-rich foods like green banana and green banana flour are best consumed raw, with minimal to no cooking. This also applies to cooked and cooled starches. When you reheat your cold rice or pasta, avoid overheating it. Gentle warming preserves the RS3, but blasting it with high heat will melt those healthy structures right back into regular starch. Finally, engineering RS5. You can intentionally create heat-stable RS5 by boiling your rice or pasta with a fat source like a teaspoon of oil, allowing the fat to bind with the starch. Just remember, only about 15% to 20% of the starch transforms this way. Since oily boiled rice isn't for everyone, you can achieve a similar effect by cooling your rice first, then stir-frying it with a healthy fat to capture both RS3 and RS5. Similarly, if you cook pasta with olive oil or cheese and then cool it, it will naturally contain both resistant starches. Just keep an eye on the portions as the added oil will increases the overall calorie count. Ultimately, maximizing resistant starch doesn't require a restrictive diet, just smarter kitchen habits. By prioritizing whole or coarsely milled grains, consuming raw sources cold, utilizing the 24-hour refrigeration trick for your leftovers, and adding a splash of healthy fat when you cook, you can effortlessly unlock the true metabolic power of your carbohydrates. Now, a quick note before we wrap up. Although current evidence often groups prebiotic benefits together, distinct dietary fibers selectively feed different bacterial families. A diverse diet is key to maximize gut microbiome richness and unlock its full health potential.